Let me tell you a little bit about how I'm coming to this. I used to teach, I guess. They made me a research professor recently, which means you sort of teach when you can because you're traveling around and you're doing a lot of research. But I'm teaching, mostly teach risk seminars at this point. This Public Communication of Science and Technology project was the reason I was recruited from the University of South Carolina. It's NC State decided they wanted to interface with their social scientists across to the engineering campus. If you've ever been to Raleigh, you'll notice that there are railroad tracks in the middle of the campus, and on one side of the tracks is engineering, which is gorgeous, with a lot of parking. And on the other side of the tracks is humanities and social sciences, which is a bunch of old buildings without air conditioning. And so one of my jobs is to try to make this a better place. And I'm not sure how I succeeded because they're going to relocate me to the Centennial campus, so I'll have better parking. I'm doing a grant on intuitive nanotoxicology and public engagement. I have a degree in biology, which helps a bit. But this whole project is to try to have a better understanding of how the public unpacks complex toxicological information that they get, how they try to make sense out of it. And I'm also working with Mark Wiesner at Duke, where the Center for Environmental Implications of Nanotechnology is, and we're working on some projects together. I'm not going to read you the paper because I think you could read it. I'm just going to introduce a bunch of questions and map some of the stuff that is going on. We added a new blog. We do a nano news feed now. We hired some graduate students, and what they're doing is going through literally all of the literature that's coming out on the internet and in print on nanoscience and doing summaries. And so you can get it on our blog. And it's there. I have 6 doctoral students I'm working with and 3 master's students on these projects. I'm going to talk a little bit about this Delphi project because this is done. And so I'm going to give you some data today, which I guess no one's seen yet. And so that'll be the new stuff. We've got about 42 sets of information out of the Delphi, and they're in 5 categories. We're going to be working with the University of South Carolina as a public service and public research center, and we're going to be doing a mirror survey to public audiences. The Delphi was with expert samples, and the Dillman we're going to be doing at South Carolina will be with public samples. The data analysis will be done in conjunction with the University of Wisconsin and Dietrich Scheufele. We're also working on a whole series of civil engagement exercises with South Carolina. And we're also working with Jennifer Kusma at the University of Minnesota on some nanofood focus group work. We just completed, believe it or not, we completed a white paper. It was in summer of 2008. It had to go through 25 agencies and departments of the National Nanotechnology Initiative, which it did. And then the administrations changed, so we had to go through the same 25 agencies and departments. And so we just completed that. So I was informed, this will be out soon, and it's a complete review of the research in risk communication over the last 4 or 5 decades. And it's about 140 pages with a pretty exhaustive bibliography. We're also done train-the-trainer projects at the National Science Foundation for the heads of departments and agencies. So Scheufele and I go up there and we play literally with these communication directors of the departments and the agencies, putting them through a series of exercises about uncertainty and risk. I work in the area of perception and public policy mostly. Generally, I've been working in the area of how to prepare the public for a trigger event. You know, if something awful did happen, what would be our response strategy? There's an assumption that if something bad happens, it might be contagious, and that a bad event in one component of nanoscience might leak over and cross over to other areas of nanoscience. And I'm not sure that theory is legitimate in this setting, but it's the concern. There's some question about whether we want to inoculate the public or not by providing them a positive anchor or positive information of nanoscience. And there's some serious ethical considerations that have to take place here. Generally, the public is disinterested in nanoscience. Under 70% of the public, about 70% of the public at most has any idea what nano is or nanotechnology is, and most of them don't. When you do the research, you find out they're actually reacting to the technology part of the word, not the nano part of the word. There was a study that was done at Texas A&M which wasn't actually published, and so we're replicating it. But there's good evidence indicating the public is overwhelmingly disinterested in science and technology policy. 10% is the highest number we've been able to come up with. The data from Texas A&M was at 7%. So if you ask the public, when you go and vote, do you actually consider science and technology policy as one of the variables you use, only about 7 to 10% say yes. Most people say no. And the ones that do say yes, if you do a deep investigation, you find out there's some catharsis. There's some event that occurred, a trigger event in their life where, an epiphany event of sorts, where someone in their family may have experienced, for example, cancer, and so they pay particularly close attention to science and technology relating to cancer. So the public really is not overly interested in this stuff, which is rough for a lot of folks to handle. But the other thing is engagement's not for everyone. There's a lot of engagement exercises. I'm not sure we're getting good data. There's this question of ecological validity where we engage the public and we bring them to settings and we talk to them about things like nanoscience. And it's a real artificial setting, and the validity of what we get from these meetings may be not very significant. The meeting the public in traditional public settings might be a more ecologically valid way of doing this, but as we realized just recently, the town hall format doesn't work very well if there's some really loud people in the room. And this has led a whole bunch of us to get together, and we put together a grant proposal already on doing social media town halls where we're going to try to support libraries to develop online facilities so for the public so can have access. And we're developing some software and platforms for public discussion using a lot of streaming video technologies and remote video feeds. One of the things about in North Carolina State is we have a doctoral program in digital media, so we have all of these kids who just love to play in this world, and so it's a wonderful resource. And so we're trying to take advantage of it where we can. In terms of what we're doing a lot of perception research. We're obviously studying media in many different settings, especially digital media. We spend less with regulators. We spend more time with digital media, obviously. The first thing we're doing is, on the extreme left, is we're trying to validate the amplification and attenuation research that took place over the years, talking about how the media can affect events. Usually the media is held responsible for amplifying the negatives of an event. Like how every storm is the storm of the century, right? They have a tendency to do this. The question becomes whether digital media has the same effect. We're not quite sure. Whether digital media could actually attenuate these events, we're also not quite sure. In terms of the center part on public perception, we're trying to figure out, at least in the grant we're working on, how the public makes sense out of complex toxicology, and trying to figure out what variables they bring into the mix and whether they are responding or not responding to group leaders. There's some superior research that's just started to surface on how variables like religiosity may be more important than any other variable in deciding how the public reacts to things like science and technology. And that needs to be investigated because in many cases it's group leader led, right? It's why people will turn to their minister for advice on things like science. And also I have a bunch of people working on the perception of public perception, which is a weird phenomenon, but what it's talking about is how the regulators perceive public perception. And they tend to exaggerate public perception of science because they think it's so important. And the public really, which is at odds with how the public feels about science and technology. And so that's the work we're doing. Right now, we're looking at media coverage from 2004 and 2007. If you look at this, this chart here, this graph here, what you end up seeing is a comparison of the 2004 and 2007 data. 2004 data was the Kaaba-Kubri data. The Kahan data is from 2007. If you notice, if you look at the people who heard little or nothing or heard some or a lot, they're pretty much the same. They haven't changed over a period of 3 years. And that phenomenon interests us on many levels. I guess the first thing you could say is the studies are really bad, and so they're useless, but I don't think that might be the case. Next, you might argue they're maxed out. In other words, we've already reached the people who are reachable or the ones that want to be reached. And so there is never going to be a major increase here. And the other is this trough phenomenon, which I'm going to show you in a few seconds. So if you look at the data sets, you can see, there really hasn't been a change when there's been a lot of media coverage between 2004 and 2007. So there's a lot of media coverage out there. The public is getting some information, and there doesn't seem to be any substantial effect. This is also true in Europe if you look at the data from Germany in 2004 and 2007. Where these two studies also report not a significant change in perceptions whatsoever. So it's not just a U.S. thing. This leads us to this area. Schäufele, Corley et al. In 2008 published this data set, which looks at 2004 and 2007. Now, you do realize that at the 50% level here, this is a random occurrence, right? So, when you ask people, what is a nano, and they give you an answer, and it's at the 50 level, it's not really that significant. But beyond all that, it suggests that there really wasn't a lot of change in 4 and 7, and we need to figure out why that's the case, because there was a lot of reporting taking place. So the information was getting out there, but it wasn't affecting public perceptions. This is a graph I used in my book, in Nano-Hype. I got the Gartner people to release it to me. This is their hype cycle graph, and it's interesting. But what phenomenon we're looking at right now is this: that there might be this trough phenomenon taking place. In other words, what we're measuring is two separate points: the point before we have the peak and the point as the peak drops down again. In other words, 2004 may be that first point, and 2007 may be the second intersection of where you see that arrow-like graphic. And if that's the case, then that could be quite interesting. It would demonstrate that this public perception is more a function of this trough phenomenon than anything else. Oh, by the way, Nano-Hype's now in Japanese, which is really kind of cool. And I'm sure everybody's going to run out and buy it. So the paper I wrote and the chapter I wrote for the folks here is about strategic uncertainty. And I guess I should explain a little bit about how this all took place. It's based on a whole bunch of assumptions. And first is that public awareness actually tends to increase fear of risks and increase apprehension of benefits. And this has generally been sustained in the research that's been taking place. But the thing is, we're not quite sure how long public awareness endures, right? There's no longitudinal studies that have been done. And so we're not quite sure, how long this takes place. We also are assuming that, a lot about nano is marketing. I mean, I know people don't want to talk about, marketing nano as a concept, but it is. And it's all based on coherent stories. And when the public starts trying to figure out what coherent stories are, they don't normally turn to science for what makes a story coherent. They turn to what they're comfortable with, which is stories, period. And so they treat nano as a story. Also, when we talk about public awareness, there's a whole bunch of heuristics the public uses that are fairly dominant. Affect tends to be the most dominant. At least that's what the Kahan research has indicated. And it's hard to disagree with that. But there's a lot of other variables that are shortcuts that the public uses when they try to examine things as complicated as nanoscience. So, to the article. I make a bunch of assumptions in the article. I talk about this concept of strategic uncertainty. Initially, I see strategic uncertainty as a rhetorical device. I wrote an article in the Journal of Nanoparticle Research which talks about risk profile shifts, which complained mostly that Friends of the Earth Australia had misused risk profiles in order to accentuate the negative effect of a document they were producing. Right, and you see this happening in a lot of other communities as well. I spent a lot of time with toxicologists, I guess because of the International Council on Nanotechnology. And you never really meet a toxicologist who says, yeah, we got enough research. Right? I mean, there's never at that point where you get to anything close to certainty. So in the chapter I wrote, I talk about this phenomenon called event horizon creep, which is pretty straightforward. It just says that things are happening at a much quicker pace. Like technologies are leapfrogging where they had it in the past. In the developing world, access to the internet is via smartphones, not via the PC, which was the interim step we had here, right, or in the West. So you have this real acceleration taking place. The second phenomenon you have is the boundaries that exist between fiction and nonfiction are dimming substantially. That the narratives built on unreal or fictive claims have more space to acquire rhetorical validity as a consequence of this. There's also an explosion of the unfamiliar and the strange, and that's also a function of digital media and the fact that there's so much information that can get out to the public in so many different ways. Then there's a proliferation of audience and stakeholders. There's a lot of stakeholder rhetoric, but to be honest, I mean, we read so many grant proposals which have the word stakeholder in them these days. We're not quite sure what that word even means anymore. It used to be someone who used to hold money when you're betting. And it's sort of changed a lot, right? It's sort of like stakeholder equals shareholder, I guess. But communication, outreach, participation, engagement, these are different things. But they're getting bundled together, and we're not quite figured out how to deal with the tension of how public spheres has often been treated as an extension of identity politics, and that's incredibly at odds with how we look at intersectional sensibilities towards science and technology as well. So we talk in the paper, in the chapter, when you read it, on uncertainty in science. I mean, science tends to generate a lot of uncertainty. There's many reasons for this, and most of you are aware of this. Some of the reasons are dictated by what science does and how science functions, right? Science functions to generate data, and the data just produces more calls for data. And so you really have a lot of uncertainty, and some is less selfless. A lot of people actually can make money out of producing uncertainty. Right? You can actually sell uncertainty as a commodity in our economy. The other thing I talk about in the chapter I wrote is about risks and its social construction. This is a real problem for folks who are in risk management to embrace the fact that risk is a social construction. It's not a bunch of numbers you multiply against one another, especially when you talk about dosage and exposure to nanoparticles. We can't even measure that. Right? I mean, it's really we've got these management algorithms that aren't really working. So and also in that chapter, I talk about how risk and decision making takes place using these rather old and defunct risk management algorithms. And I also talk obviously about public science in this, and I'm sure if you read it, you can pretty much see what everyone else has always said about public science. Yes, it's there. It's not science in an objective sense, as most scientists would claim it to be. But it leads to a bunch of research hypotheses, which I then talk about in the paper. The paper also does something which looks at 4 scenarios and balances it against the precautionary principle. This precautionary principle has really been beaten to hell, and there's no reason it should be. I mean, there's hard and soft versions of this thing, right? You know, it's not just ban everything, right? So what I do in the paper is I look at high uncertainty, high risk situations, talk about strict regulation. When there's some level of uncertainty and some level of risk, how voluntary stewardship is an approach that's being used, whether acceptable or not. Then I look at some uncertainty and low risk and talk about best common good practices. One of the things we did in ICON is the Good Nano Wiki, where we spent a lot of time trying to figure out what best practices are. And then I look at low uncertainty and low risk and talk about how self-regulation works or how it doesn't work. But you can read that chapter. We've got to deal with digital media. Data indicates demographics favor net newsers in the USA. There's Pew Data on this. And I often have to tell most of the people I consult with that they've got to decide their web resources as digital media. And net resources are known to amplify risk messages. And there's not a lot of evidence that indicates it attenuates it. But, you know, we've got to get on course with social networking. And that's mostly because of the Pew Data, where the Pew Data indicates that, you know, TV viewership has dropped substantially for some demographics, while the World Wide Web has increased substantially. And this is in terms of people getting news, right? And so for certain age ranges, it's shifted almost entirely to digital media, with the exception being some of the older demographics. But if you look at the younger demographics in the age ranges from 19 up to 34, you're going to see that, you know, it's almost all going to be about social media and digital media, and that's where we're going, and that's where we need to focus. That having been said, here's some new data. We did the Delphi. We investigated with a bunch of experts, asked them what current or predictable future uses of nanoparticles are potentially or actually problematic to environmental health and science. You know, and the top 5 came out from antimicrobial applications down to fuel additives. But, I mean, you have to understand, I mean, there's not a high level of coherence here, which is really interesting, right? The concurrence that we discovered was that when you ask the experts what's going to be problematic, they can't agree on any of this. The only data we got which they did agree was what characteristics of nanoparticles they feel might be problematic in terms of environmental health and safety. And to give you that data, it's also in the report. We asked them, we did the Delphi. The thing about the Delphi, which is fine, is that you don't prime your audience. You ask them to come up with the data sets, right? You don't give them a list to check off. They have to generate their own list. And so what happened is the top 5 characteristics that they deemed were problematic were whether a particle is reactive, its size, its composition, its surface area to volume, and its surface charge were the top 5 in that order. High level of concurrence, right? The experts in the field in 5 subcategories all agreed. When we got to this area and we started asking them about applications, there was very low concordance, right? There was very little agreement whatsoever. And so, you know, when the public has to deal with all this stuff, and you're asking them to react to all this information, this is a bit of an issue for them because usually they turn to the experts at the government hearings and they say, hey, what's up? And the government, in the hearings, they say, hey, there's all these products, and these products might be problematic. It depends which expert you brought up because they probably aren't going to agree with any other expert. Right? There's no data that they have that makes them uniquely privileged to make these comments. We asked them what current and predictable future products involving the applications of nanoparticles are potentially or actually problematic to environmental health and safety. And when we did that, we got this list, which, if you notice, it should be a lot like the previous one, but isn't. And the level of concordance is low as well. I'm sure Jennifer would be really upset that food packaging and food additives is so low on the list from the experts, but that's what they concluded. And finally, we asked, what applications or products do you assume the public believes are problematic or actually problematic to environmental health and safety? So we're asking the experts, predict what you think the public thinks will be bad, right? And they go, cosmetics, sunscreens, antimicrobial clothing, food additives, and nanobots, right? I mean, it just pops up, and it got a pretty high ranking. And there was, some level of concordance and agreement on this. So what we're doing in the follow-up Dillman study is we're asking the public what they think the experts think the public thinks is problematic for EHS, right? And so we'll have a pretty comprehensive data set at that point to get an indication of how much disagreement there actually is here. And truth be told, from what we can tell at this point, turning to the experts and asking the experts what they think the public's concerned about is a waste of time, right? Because in the science field, there's no concordance. And we ask chemists, toxicologists, engineers, chemical engineers, environmental engineers, and public policy people in science, right? So it's a fairly diverse group of folks. And there's no wonder there's such a high level of uncertainty. So let go of your misperceptions. Risk analysis is high uncertainty. We may need a new approach to this study. First of all, stop worrying about popular culture. These are interesting to read. They're fun to watch. They have no effect whatsoever on the public. None of the data supports this whatsoever. There's an Oldenburg study from a decade ago. It was the best you could get. And no one's been able to replicate that the public looks at popular culture to figure out what's going on. Science education, great idea, but it doesn't affect public perception. Right? Public's already decided they don't want a science education. Right? That's why they're not scientists. Right? They've decided. And if you're going to teach them about science, don't expect them to go, ooh, thank you. Now everything is better, because that doesn't happen. Public engagement is expensive and mildly productive. It can be more productive if you decide what your goals are, but I think that's something we probably need to start looking at. All scientists need to work together. Nagging is counterproductive. I mean, you can't just nag the scientists. I mean, I deal with this all the time. Where I go meet these engineers and these scientists, and they're sitting in a room, and they've been accustomed to folks coming in and blaming them for all of the world's ills. And they know they're responsible for some of the world's ills. They don't need to be reminded. But we really need to find a way to focus on them. We did develop an algorithm that's in the white paper. It's up here. Deborah has a copy of the PowerPoint. You can play around with it. The reason it's kind of fun is that it discounts the tails. In other words, the highly exaggerated and improbable scenarios when it looks at how to communicate risk. And if anybody wants to criticize it, that'd be great. At the bottom, there's a risk communication model we designed. And being from the South, we use NASCAR because you have to if you're in the South. But risk communication is a lot like NASCAR. And we designed this for your edification and some of your entertainment. Risk communication to the public is what we've been doing at NC State. We're supported by the NERC grant predominantly. This is my email address. Please feel encouraged to contact me. I do answer my email. Thank you.